Good morning to all students. I am Krishnamoorthi, Assistant Professor, Department of Mechanical Engineering. Today I talk about the subject engineering mechanics. Do you know what is the engineering mechanics? What is the meaning of engineering? What is the meaning of mechanics? So I will explain. So first the introduction to the engineering mechanics. So engineering, what is the engineering? So what is the mechanics? The mechanics is the branches of the science. For example, the physics is a mechanics, the chemistry is a mechanics. So these are the mechanics of branches of mechanics and engineering mechanics. So first we are discussing about the topics, the content of the presentation, general introduction of engineering. So what is the introduction of engineering? We will explain. Mechanics, SI units of systems. So what is the unit of system? There are more number of units is in the all subject. For example, if you talk of the mechanical subject, list of the subject, the mechanical engineering mechanics and DME, design of machine element, strength of material. So lot of the subject we will discuss about the what is the system of units, and then next we are talking about the concept of force. So there are more types of force in the all subject we will discuss. So next, fundamental concept of scalar and vector. So what is a scalar, what is a vector, we will discuss. And next, last topic, quantities. So what is the quantities? So these topics are also we will discuss. So then next slide is general introduction engineering mechanics. So what is the engineering mechanics? Do you know? The engineering mechanics, there are split in the two types, the statics of mechanics, the dynamic of mechanics. So what is the statics of mechanics? For example, we are standing in this place, this is the statics, because I don't move any other place. So this is a statics of example of statics. What is called dynamics? So dynamics is moving. Now I move the one place to another place. This is called dynamics. So this is the fundamental of mechanics. This is the fundamental of mechanics. You don't understand the statics and the dynamics, you can't understand the engineering mechanics subject. So first you understand the difference between statics and dynamics. The statics is any other object, any other matters does not move. For example, if you apply the force on the object will be moved. If don't apply the force, the object can't move. So this is the example of statics and dynamics. Statics, what is the definition of statics? The definition of statics is we don't put the force or any other external force or internal force, the object does not move. If apply the force, the object will be moving. That is called statics of definition of mechanics. So next, the statics only the topics, the dynamics split to the kinetics and the kinematics. The what is the dynamics? Dynamics is the moving object. It is called dynamics. So the dynamics split to the kinetics and the kinematics. So what is the difference between kinetics and kinematics? The kinetics only consider the force, that is called kinetics. The kinematics, they are considering force and direction. We are considering force and direction. So if you are considering force and direction, that is called kinematics. If only considering force, that is called kinetics. So this is the difference between kinetics and kinematics. So we will move to next slide. So this is the example of, this is the animation video, this is the example of static load and dynamic load. See the image, the one person standing in the one place, this man don't move to another place. So this is called static load. So see the next image, this is the example of dynamic load. So see the man is moving. He is not standing. He is walking one place to another place. So this is the example of dynamic load. Understand? Concept of force. Do you know force? What is called force? So there are more types of force in there in all subject. So the few types of force we will discuss about. The first one is the woman pull the one object, one weight. So this is the push. The man pushed the object. So this is the pushing force. So go to next image. The man pull the arrow. The pull the arch. So this is called the pulling force. So this is called push force. This is called pulling force. The third one, this is called the magnetic force. The man holding the magnet. The magnet creates the magnetic field. So the object will be absorbed. So what will happen? The magnetic field creating. So the steel object is absorbed. So this is called magnetic force. So next one, gravitational force. See the image. The man sitting under the tree. Look at the apple. The apple fall down the ground. How it's happen? Because the gravitational force. The earth having gravitational force. There are 9 planets in the world, in the solar system. The 9 planets having the gravitation force. So what is the numerical number of gravitation force in the earth? 9.81 meter per second square. So this is the value of the earth gravitational force. So next one, this is called friction. Friction means friction force. What is called frictional force? See the object. The man sliding the angle of the floor. The man sliding the angle of floor. So if the body or any other object moving the table or moving the ground, the frictional force will be created under the. Sir, yeah, sir, மாறிட்டே இருக்கு. கை வச்சா மாறும். ஸோ ஒரு ஸ்டாப் பண்ணுங்க. So see the next one, last one image. The woman skating the underground. So this is called acceleration of the force. What is the difference? What is the definition of acceleration force? The acceleration force is ratio between velocity and time. It is called the acceleration force. So we are considering time and force. So this is called acceleration of force. So next one, effect of force. So what is the effect of force? See, it may change the magnitude of the motion, it may change the direction of motion. So if for example, the magnetic force applying on the one object, if change the magnetic direction, the object change the moving direction. So it is called the magnetic force of directional motion. When you apply the force in which direction, so the body will move that direction. It is called the direction of motion. It is called the direction of motion. So next one, this is the 4 characteristics of force. So what is the characteristics of force? The first one, direction. So which direction apply to the force on the object? And second one, magnitude. So So magnitude is what is called what is the definition of magnitude? So what is called the magnitude? The magnitude is depend upon the direction and force. So only consider the force, it is called stress or load. If you considering the direction and force, it is called magnitude. So clear? So next one, point on which it act. The force acting on only the point or only on the area. So this is the different. If you apply the force on the one object, what types of force you apply on the object? Point contact force only object or area contact of the force on the object. So this is a difference. You clearly difference about the what types of load acting on the object. And next one, line of action. So line of action, what is a line of action means? The force acting only parallel or series. So different types of force are acting on the object. First, you force acting only parallel axis or the force acting on the series line axis. So you briefly or clearly understood. So next one, the mechanics or ideologies of the object. See, the particle, a body with mass but the dimension that can be neglected. For the example, the sun and earth. The earth rotation depend upon the orbit. The size of the earth is insignificant compared to the size of its orbit. If the orbit size is very less, the planet size of also depend upon the orbit size. So this is the for example of simplified application of the mechanics of ideation. So next one, the mechanics fundamental of the concept. Fundamental and concept of the mechanics. What is the fundamental? So see the fundamental of mechanics, the length, time, mass, force, and force is a vector quantity. These types of the parameter considered to the fundamental of mechanics. The first one, length. The need to locate the position of the point in space and describe size of the physical system. For example, distance. It is called the length. So next one, geometric properties. What is the geometric properties? Like circle, semicircle, triangle. So these all are the geometric properties. And next one, time. What is the fundamental mechanics of time? Measure of sections of event, basic quantity in dynamics. So time, what is the unit of time? Is a second. So next one, next parameter, mass. What is called mass? The quantity of matter in a body. The quantity of matter in a body. So that is called mass. So measure of the inertia of your body, it resistant to change in velocity. So what is the mass of your body? So I am having a 60 kg mass. I am having a 60 kg mass. So that's all this is the example of mass. This is the example of mass. And last one, force. The force action of on your body on another characterized by its magnitude, direction of its action and its point of the application. The force is called ratio between load and area. Ratio between load and area. So it is called force. Next one, the Newton mechanics. What is called Newton mechanics? Before I explained, length, time and mass are absolutely concept of independent of each other. These parameters are not dependent in one parameter to another parameter. These are all single parameter, independent. So next slide, what is a scalar? When you talk about the units, quantity, you compulsory know about the scalar quantity, you definitely know about the vector quantity. So there are different. What is the scalar quantity? What is the vector quantity? I will explain. The scalar quantity are measured with numbers and units. The scalar quantity are measured with numbers and units. See the example length. See the first image, the example length. Example 16 centimeter. 16 centimeter. So this is called the scalar. Only consider the one parameter. If you considering two parameter, that is called vector quantity. For example, see the image, first image, acceleration. What is the acceleration? The ratio between the velocity and the time. So velocity is the one scalar quantity, time is the one scalar quantity. So we are using two quantity. We are using two scalar quantity. That is called vector quantity. So vector quantities are measured with the numbers and units and but also having specific direction. So vector quantity you will consider direction also, not only numbers and unit, you considering specific direction also. So this is the example of vector and scalar quantity. So next slide, speed or velocity. The distance is a scalar and displacement is a vector. Similarly, speed is scalar and velocity is vector. Speed is the rate of the change of distance in the direction of travel. The speedometer is car measured speed. Velocity is a rate of change of displacement and has both magnitude and direction. Average of both can be useful. This is the formula. The first, speed. So what is called speed? How to measure the speed in automobile industry, in bike or car, bus, flight, anything. The speedometer in the car, in the automobile industry, the speedometer measure the speed. So speed equal, average speed equal distance by time, ratio between distance and time. It is called speed. How to measure the speed? For example, I am running the 400 kilometer. Now I am starting in this place. Gradually I increase the speed. How to measure my speed? I am how many distance covered, that is called distance. For example, I covered 1 kilometer for 2 minutes, that is called my speed, running speed. Understand? So speed, ratio of the speed. How to calculate the speed? The ratio between distance by time. Next, velocity. How to calculate the velocity? What is the difference between speed and velocity? Speed only considering distance and time, but velocity, displacement. The average velocity equal to displacement by time. So this is called the velocity and the speed. What is called displacement? What is the difference between distance and the displacement? Distance only consider the length, but the displacement considering direction and length. So this is the difference between displacement and distance. So clear? So next, So that's all my PPT. Thank you to you all.